In the summer of 536, the sun seemed to lose its strength. Across the Mediterranean, people described pale light, weak warmth, and produce ruined by bad weather. Far beyond them, trees recorded exceptional cold across much of the northern hemisphere. That is why 536 is often called the worst year in human history, and why the truth of that title depends on what happened after the sun dimmed. For people living from one harvest to the next, summer was the narrow window in which grain, fruit, and fodder had to grow. One cold season could empty stores. Another shock before the fields and stores recovered could turn hardship into a lasting crisis. The explanation is simple. A powerful eruption sent sulfur above ordinary weather. There, in the upper atmosphere, the gas changed into tiny droplets that reflected part of the sunlight back towards space. This was not a blanket of ash hanging in the sky for years. Most volcanic ash falls within days or weeks. The longer cooling comes mainly from those high, reflective sulfate droplets. The first clue comes from a man named Procopius. He wrote that the sun gave light without its usual brightness, like the moon, for an entire year. Another writer, John Lytus, connected the dim sun with bad weather and destroyed produce. These were observations, not measurements. Their dates and descriptions are not all equally secure, but they describe the visible result of a process that left physical evidence far beyond the Mediterranean. Less sunlight reaching the ground means less summer warmth. In 536, reconstructed European summer temperatures fell about 1.6 to 2.5 degrees Celsius below the average of the previous 30 years. That number sounds small until we remember what it measures. It is an average across a season and a region, not the temperature on one unusually cold morning. It represents a broad shift in the growing conditions on which harvests depended. No one in 536 could see the eruption in those terms. We can, because the atmosphere left a record in ice. Each year, snow settled over Greenland and Antarctica. Compressed over time, those layers became ice. Scientists can drill out long cylinders through them and read the chemistry of one layer after another. In the layer dated to late 535 or early 536, Greenland ice holds a large volcanic sulfate signal and microscopic pieces of volcanic glass. That confirms a major northern hemisphere volcanic episode at the right time. But the ice does not give us the name of the mountain. The glass found near the 536 layer includes at least 3 different chemical compositions, and researchers have not matched them firmly to one source. The particles are also distinct from the Icelandic ash once used to support a popular explanation. So the first mystery is solved only halfway. A major eruption dimmed the sun, but its location remains unknown. The next witness is wood. In a normal year, a tree adds a layer of growth. The width and structure of that layer respond to the conditions in which the tree grew. When summer turns suddenly cold, growth can narrow, and the wood cells can form abnormally. Across tree records from North America, Europe, and Asia, the summer of 536 stands out as exceptionally cold. Cell-level damage appears across many northern hemisphere sites outside the tropics in 536 and 537. Yet 6 sampled sites in the southern hemisphere do not show a comparable response. That boundary matters. The evidence does not describe the whole planet with equal confidence. It supports a vast northern hemisphere event, not a measured global apocalypse. And still, one terrible summer does not fully explain the title. The deeper answer lies in what happened before recovery was complete. Around 539 or 540, another large eruption left sulfate in ice from both Greenland and Antarctica. That pattern points to a second event, probably in the tropics. The cooling returned. In Europe, reconstructed summer temperatures in 541 fell about 1.4 to 2.7 degrees Celsius below the earlier 30-year average, and cold conditions across the northern hemisphere persisted unevenly towards the middle of the century. In one major tree growth reconstruction, the decade from 536 to 545 is the coldest in 2,500 years of Northern Hemisphere evidence. This is the turning point. The first eruption strained harvests and reserves. The second denied many communities a clean recovery. The force of the story is not one impossible day. It is repeated pressure. Then, in 541, a new disaster entered the record: plague. Ancient DNA from 6th century victims confirms the presence of Yersinia pestis, the bacterium that causes plague. This outbreak began what historians call the first plague pandemic. It is tempting to draw one straight line: volcano, cold, failed harvests, plague. The evidence does not allow that certainty. Volcanic cooling may have shaped the conditions in which societies faced disease, but a direct causal chain is difficult to prove. Even the scale of the plague's long-term damage is disputed. Some historians argue that claims of population collapse across the empire go beyond the evidence. Others point to contemporary accounts, ancient DNA, and other records as signs of major regional effects. The plague, therefore, belongs in this story as an added shock, not as a hidden event inside the calendar year 536, and not as a consequence we can simply blame on a volcano. So, was 536 really the worst year in human history? Taken literally, no evidence can prove that. The phrase is a modern judgment, not the result of a scientific ranking. Other years were deadlier in particular places, and the strongest physical evidence for 536 does not cover every region equally. But the title holds a more careful truth. In 536, people watched the sun lose its familiar brightness. Ice shows that a major eruption had reached the atmosphere. Trees show exceptional cold across much of the northern hemisphere. A second eruption renewed the shock before recovery, and plague followed in 541. What made 536 so punishing was not that every disaster happened at once. It was that the first blow opened a sequence, and each new shock arrived in a world with less room to absorb it. That is the most defensible verdict. Not the worst year for every human being, but the year the sky changed and an exceptional compound crisis began. And one part of the story is still missing. The ice has preserved the sulfur. The trees have preserved the cold. Writers preserved the strange light. But the volcano that began it all has yet to give us its name.
Hey, this is Adam from The Wider Why. We make clear, engaging videos about science, history, technology, and more. Like and subscribe to see the bigger story.